Serializing to and from JSON in .NET is a highly optimized thing, but the performance that you get depends a little bit on how you use it. Let's mash on that. Simon.
Hi everyone, and welcome to another episode of the Asp.Net Monsters. In today's episode, we are going to check out how fast it is to serialize stuff to JSON, which is just like the 2010s XML. Is there an XML for the 2020s yet?
Be YAML, right?
Is it YAML? Oh,
yeah.
I actually definitely living in the worst universe.
Mm-hmm.
Part of me always wished, though, that there was a James, because growing up, my brother's name was Jason, and I was always called Jason. So when this came up, it was like a slap in the face, because he doesn't even write code.
And he has a serialization format named after him.
Unfair.
So unfair.
Awful.
You know what YAML stands for, right? Yelling at my laptop.
Yeah, it's another markup language.
I was hoping there would be a joke version of it.
I saw a t-shirt somebody posted on Twitter yelling at my laptop. That's pretty good. Okay, so really simple demo application that we're going to build, and then we're going to put some benchmarks around it to kind of look at a couple different patterns for just serializing and deserializing a blob of JSON from our local disk. After that, we're going to take it in future episodes a little bit further and look at what this might look like inside of like a web API where we might be interacting with like blobs or files coming from the client or maybe over to blob storage. But we're just going to start with like a simple console app here. So let's JSON some things. I have a person class, a little simple person class with a few string properties and a couple number properties. Nothing major there. And then what I've done is created a couple of different files, one that's fairly small, and I can format this just so that you see what it looks like, but it's just an array of those person classes serialized out here. Some of these people have a lot of kids.
Jeez. Busy.
It was randomly generated. I'm going to leave that just kind of minified so I want it as small as possible. And then I have a bigger one that has a lot more data in it with like 1,500 people in it. And if I go look at what that looks like on disk, how big are these files? So the big one is like 128K and the smaller one is 9K. So just to give you an idea of what we're working with. But let's take a look at like how would we do this I'm using System.Text.Json to do the serialization, which is the built-in serializer that ships with .NET as of, I can't remember what version of .NET Core they added that, but it's there now, so that's what we're using. And it's fast. It's definitely very, very optimized, as I was saying. But here's the pattern that I would sometimes see for how to do that, how to serialize. Let's say we'll start with deserializing. So I'm going to get some objects. I'm going to load up that file that's on disk and then deserialize it so that I have those objects in memory. So what I'll often see there is we'll see like file dot read all text. Might as well do the async version of that. And I give it the pass, it'd be like people.json. And then that just gives me my my people. So this would give me I have to tell it. That's the people JSON. So that's the string containing all the JSON from that file. And then we might do JSON serializer.deserialize. And I would tell it that I want to get a person array. And then I pass it my people JSON string. So now I have my people, and this would be my array of person that comes back from that. And I don't know what we want to write out. I could just do like a console.writeLine. People.length just to show how many are in there. And then I'll do a .NET run. So it says we got 100 that were loaded. It seems like it was fast. Don't know how fast, but we'll get into that. So now let's load that bigger one. Should still run really quick. Like it's fast enough that we're not going to notice the difference in speed here, but it loaded up those 1,500 people and they appear to be in memory. Good enough. That's one of the patterns that I see. But it's always kind of struck me as not the most efficient way of doing things, because what we're doing is we're taking all of that JSON that exists inside of that file, we're loading it into a string, right? And then we're taking that string and passing it to the JSON deserializer to go and read that string and convert it into person classes. But the deserializer has another way of doing things. I'll just comment this out. And what we could do is, if we look at the different overloads here, I think my IntelliSense will give me that. The very first one is it just takes in a stream, right? So it's always felt like maybe this isn't very optimal. It would be a little bit faster, more efficient in terms of like not having to create those strings, load the whole file into memory, and then also create all the person classes in memory. So maybe it's faster if we do this a different way. So we could open a read stream. So instead of loading up all of that, we would say using bar stream equals file.openRead, and then I would give it the path. So that would be like the people.json. And then I would pass my stream here, and this would become the thing that I do asynchronously, probably. I call the async version of that, and put my await here. And that should do the same thing, right? But it's not going to create that string that lives in between, that lives in memory. So let's see, if I run that now, I should get 100. There's my 100. And if I run it against the bigger one, again, should get the 1500. Okay, so I think this is faster, but like how much faster is it? I don't really know. And that,
42.
fortunately, there is 42. It's 42 faster. 42 what? Speed.
Units.
So fortunately, there's a really good tool in the .NET ecosystem for benchmarking things like this called BenchmarkDotNet. So I've already added that in here. I have GenFoo in here because I originally used that to generate those fake people, which is why there's weird numbers like 80 children.
88 children.
But I've added benchmark.net, and the only other package reference I've added here is System.Text.Json. So let's take a look at how you use benchmark.net. Now, it's a super easy tool to use. I'm actually just going to kill this code that I had. I'll leave the console write line in there. But all we do, the way benchmark.net works is it always has to be a console app. So we already have a console app, perfect. And then what we do to kick it off is we just say benchmark runner dot run, and then we give it the optionally some config, and we point it at an assembly that's going to contain the benchmarks that we want to run. So I can just say type of program, which is my current class, dot assembly, so the current assembly. So I just tell it, go and run any benchmarks that you find in this assembly. Cool. Now I need to actually create some of those. So let's start with the first one, it being deserializing, so that thing that we just did. So I'm just going to create a class called JSON deserialization benchmark. I don't know why I care that I spelled that right, but it's bothering me, and I'm going to spell it right. Okay, and then we're going to create two benchmarks. So one with that first code that we did. I'm just going to copy and paste that in here so that I don't have to type it in again. So here we're going to read from a file where we create a string first. And then the second one, we're going to do it from a stream. And the way we tell the benchmark.net framework that these are benchmarks that we want to run is by adding this benchmark tag to it. So for the two methods that I wanted to test, I'm going to add the benchmark tag, and then I'm going to tell it that this first one is the baseline, because what I want to know is how much faster is it to do it from stream, and is it faster? Maybe I'm wrong about this. That's happened to me quite a few times lately when I'm doing performance-related things where I think that something is going to be faster if I do it a different way, and then I go and test it, and turns out I'm totally wrong. Okay, so now we have one set of benchmarks. If I run this console app, it's going to go and find this benchmark and run it with kind of some default, what they call diagnosers on it. And the default one is just like the performance in terms of how long it takes. I also am curious though about memory, so I'm going to add this attribute here for the memory diagnoser so I can include that in my test run. Okay, so that's it. Then I just do .NET run again and run the benchmarks. And it's going to fail because it says, well, this is not like you're trying to run that in debug and you shouldn't be doing performance benchmarking in debug because it's not very accurate. So it's just reminding me I need to do a -c for configuration and tell it that I want to do a release config. So it's going to go and build it in release and then go and run my benchmarks. Now this does take a little while because it does a whole bunch of like warming up and measuring how long it takes just to get started, and then it does a bunch of runs of the actual workload for you, and then calculates the statistics on that, throws away any outliers, and then finally gives you the results.
Wow, that's pretty comprehensive right out of the box.
It is like it's a lot more than just doing, the other way that I'll see people try to do some benchmarking is like you do a stopwatch
Right.
.new.
Well, yeah, and then the other thing is too is that I mean, if you've built a decent library with public facing things that you want to benchmark, all you have to do is cut um, a console app and reference those libraries, and you're just going
Yeah,
to make your benchmarks with simple calls, right?
exactly.
Yeah.
Okay, so we have our results, and it spits it out in a few different ways. So it's in the console here, and we can kind of see the. Oh, I didn't get my memory stuff in here for some reason. You know what? Probably because I didn't save the file before I ran it. Let's run that again because the memory part is pretty interesting too. But while it's running, I can go and we can look at the results from last time. So it spits it out in a bunch of different formats by default, which is kind of nice. One of those is like an HTML file, CSV file, and one of them is a Markdown file.
Oh, neat.
But right off the bat, it shows us that uh, it doing it from stream was in fact faster. Uh, the the one ratio gets applied to like what we marked as our baseline. That one is
Baseline.
1, and then it's saying 80. This one is 83% of the time it takes to do the baseline. So it's a fair bit faster, but like we're talking really small numbers here, right? It's 465
Is that
microseconds,
microseconds?
which is 1,000 nanoseconds, and 1,000 nanoseconds is, if I got that right, is a millisecond. So like really small numbers anyway.
Right.
Okay, so that updated now with the additional information for the memory allocations. So with that memory diagnoser, so we can diagnoser. This time it came out a little bit faster. Even there is some variance still when you run this from time to time, but gives us an idea at least. So this one, it's saying that we had to allocate 77 kilobytes of memory to do the work. Because and I think that's largely just because we're creating that intermediary string that we don't really need, right? And then doing it the other way where we just use the stream to do the deserialization, we're down to only 20 kb. There's just less memory being allocated, which means there's less time spent doing garbage collection, which is what these two columns are showing us. And so my theory was right, it is faster. Now, does it matter that it's faster when we're talking these kinds of numbers? Probably not if it's a console app, right? But if this were a server app where this is happening a lot and our server is under like a significant amount of load, then yeah, maybe this probably does matter because it means we're using less resources, which means we can serve more
Yeah.
users with the same amount of hardware, and we're not
It,
spending
it's
as
not a
much.
it's not a one-to-one, but you could theorize that if you're saving 80% or 20% of your processing cycles and you're paying for usage, then that is a considerable saving. And I was actually just going to ask you how big of a difference that was when we went to the bigger block because
Yeah,
it was only at 77K, and that's obviously just for the
that's right.
18K file that you had.
So there's a couple different ways that I wanted to look at this. So let's start with the bigger file and see how that changes things. I did run this earlier, and I can't actually remember what the what it was. So we'll have a look. And then I'm going to do the next thing I'm going to do after this one is I'm going to run this a bunch in parallel for each test, just to get an idea of like if we were doing this a whole bunch, like in a server process where this was happening, with as requests are being processed across multiple threads, what kind of a difference would it make there? Just to see it look at, like, it's hard to visualize this when we're talking about microseconds because they're such tiny things that it's harder to really picture what kind of a difference that means.
Right.
Okay, so that one's done. And with the bigger one, it's actually a bigger difference. Like we're talking, a more substantial difference or what feels like a more substantial difference because we're talking bigger numbers in terms of how much was allocated. So we're talking, 800K instead of 285K, and our ratio is 0.8 this time. So it's,
Similar.
we're in the millisecond range now with the timing on this, and that starts to feel a little bit more significant.
But it's the thing that I'm noticing there is the Gen 2 memory cleanup, which is generally not good, right? Like we want things to be deallocated in the earliest generation possible.
That's right. And that probably is where the time is being spent, is in those in that garbage collection. Okay, so I'm going to do something that's a little bit crazy. I don't know if this even makes sense from a testing perspective, but as I said, I'm going to run this in a parallel for each, just to spin up like a bunch of threads and do this all asynchronously. So what I'm going to do here is just say, I'm just going to kind of cheat and say enumerable dot range 1 to, I'll call it 10,000. And then I'm going to go and run this method asynchronously.
Snick.
Async. Something's not liking that. I'm just going to copy it, because I do have it here as a little snippet that I know does work. Okay. So what this is going to do is go and run this on a bunch of threads asynchronously until it's done it 10,000 times. And it's going to do that for every test run. I'm going to do that on both places here. And we'll compare the results in this scenario and see what it looks like. I'm expecting it to be very similar to this, but with numbers that are bigger. We'll see. I'm going to pop open Task Manager here too, just to have a peek at what my resource usage looks like while it's doing this. I don't think anything gets bottlenecked when I'm running this test, but we'll just have a peek here and see. I'm going to be hitting I presume my hard drive fairly hard doing that, but I don't think it's going to be a bottleneck there. And the CPU is doing quite a bit of work. Certainly more than it was doing the first time around.
Nice flex on the processor there.
Indeed.
There's a few cores.
I'll just check it out.
There's much faster CPUs out there now, though.
I don't know about much faster. That's probably still top 10.
Well, this is just the 16-core version, right? It's not the 128-core version. Just. The thing I wanted to check here is just making sure that I'm not like completely bottlenecked on my disk I/O, because that would kind of throw off the results, I think, if I did that. But it looks like it's fine. It shouldn't have done anything too crazy here. Okay, what does that look like? Okay, so actually pretty similar ratio-wise. But now we're talking seconds instead of milliseconds. So I don't know, easier for me to grasp, I think, the bigger the number gets in terms of how big the difference is. And then you really see that difference when you're talking megabytes, that we're at 755 megabytes, not 200 megabytes. So it looks like every step that we went, it was like mostly the same ratios, which isn't always the case when you benchmark these things, but in this case it was. So you can kind of see how I think this does make a pretty big difference if it's something that you're doing a lot in your process. If it's something that happens once in a console app, not a big deal and not worth optimizing probably, but something to watch out for. I think we have time. Let's just do one more benchmark here, and we'll do, I'm going to comment this one out just so that it doesn't run everything and take too long, but I'm going to do a serialization one. So we'll go the other way around, where we test the serialization, because the same pattern kind of goes both directions. So often I'll see this too, where we do a JSON serializer.serialize. We pass it our list of people, which what I'm doing here, just to back up in this benchmark, is in the constructor. I'm deserializing that from disk so that I have it in memory. This just happens the one time when it creates the benchmark, and then it's going to run this method like over and over and over again. It's just this part that it's going to measure, not the constructor piece. So that's just getting the data for me. Complaining about nullability stuff. Okay, so I have this people array in memory. I serialize it to a string, and then I pass that string to write it out to a file using file.writeAllText. Using that as my baseline, I would like to compare that to doing it in a stream fashion, where instead I do a file.openWrite and get a stream, and then I pass that stream over to the serialization method and allow it to write out to the stream without having that string in between. So let's run that and see if my theory there holds that it would be any faster to do it this way. I'm going to be writing out a bunch of files to disk because I'm creating all these random GUID files. Those are going to show up here under bin release net60. I should see just like a bunch of these files start to show up eventually. I think they end up under here. There's a GUID folder that gets created just for that run. So I'd have to find the one that actually is running this version, this instance. But somewhere inside of my bin folders, nested deep in there, I'm going to be creating all of these JSON files, which I'm probably going to want to clean up after.
Probably.
But more likely, I will just forget about it.
So while that's plugging away, Dave, if I were to incorporate this into like a build process, is this something where you would want to, like, I'm thinking of some things that I've done in the past where performance is a concern and we didn't want to push out something that fell behind the previous performance benchmark, right?
I mean, it is a command line tool, so I think it's pretty easy in terms of incorporating it into a build pipeline. And
right.
There are a series of different reporters. I think that one of those reporters gives you like a test kind of report that you could probably visualize inside of like an Azure DevOps test results pane or something. I haven't played around with that, but I know it's definitely something that you can do. But yeah, I don't know the answer specifically on how.
Okay. Yeah. No. Performance gates on a release process aren't too common, but they are a thing that can happen. So.
Yeah, for sure. So it's actually done running the test, but it's cleaning up all those artifacts, which takes some time. And so I actually don't have to remember to go and delete those files. It's doing it for me. It's just taking a while to do it. But let's take a look at our report. So this was for the serialization benchmark. And in this case, again, very similar ratio of the time. So we're looking at 0.85. Again, we're in that microseconds or whichever this is. And but again, we're allocating a lot less which is what we expected. Very, very similar results. We'll run that again one more time using the bigger list of people just to see what that looks like. And then we'll call it a day, because I think we've probably generally proven or validated what I suspected, which was that it would be faster to do this using a stream versus serializing to and from a string in between our objects and the file. One last run.
Well, it looks like we've proven it, but it might just be fake news. Like maybe
you still don't believe it?
These might just be results generated from mainstream media. So,
is there anything we can do to prove this to you?
I have my beliefs.
I agree with your beliefs about gluten, but other things less so.
Lots of stats that it throws at me that I just generally ignore, but I'm thinking are actually quite useful.
So this, like, I've been thinking of this benchmarking tool, like BenchmarkDotNet, as really like for these pretty narrow benchmarks where you're doing things like optimizing individual function calls and something that wouldn't rely on things which are external factors like disk I/O or network I/O, those sorts of things. So would you tend to keep it in that space?
Generally, yes, but I have been experimenting with it in a couple places where you are still looking at an external dependency, like interacting with those things. I used it one time to measure some different options for how to interact with a database. And so that what I see then, like if you're dealing with an external dependency like that, the results are a lot more variable. So you can't really pin it down to this is for sure 15% faster or whatever, because it varies from run to run, but you can get a sense of this is generally about that much faster. And or it's generally not a big enough difference to matter in this case. We're optimizing the wrong thing. So it can still be used to give you a bit of a sense of if you're going in the right direction. Okay, so that's done now too. And
wow,
a much bigger difference actually this time around.
I'm looking at that allocation though, and even the memory cleanup, garbage. Better. Yeah.
So that's an even bigger difference this time around. With, it's a fairly simple change, but good to know. I was on the right track, at least with my thinking on that. And that's where I like to use this tool, is just this BenchmarkDotNet tool, is to validate my theories on if I'm doing the right thing. And then it helps to, like if you need people to review your PRs, it's a lot easier if you can submit this information, right? Saying, I think it's faster to do it this way. And also here's the proof of how much faster it is.
Well, I mean, we say proof.
Some evidence.
Yeah.
Well, that's awesome, Dave.
That's it for today. And as I said, we'll look at taking this a few steps further. One of the places where I'm especially interested in looking at this is in how we interact with blob storage in Azure. And how we use that SDK to pull back streams instead of having to read things back into some intermediary string. How can we do that in the most optimal way?
Interesting.
Awesome.
All right. Well, thank you everybody for joining us on today's episode. Remember to like, comment, and share, and we'll see everybody next week.
Mash on that subscribe button. Cheers.